read this whole question. It's very long. So I'm going to jump down and see what are they asking me to do here. Using the data, explain which material would be best to include in the lunchbox. Okay, so what are they asking me here? Someone share with me. Nasir, I want you to have a seat. Okay. What is this question asking us? Yes, Thomas.
It's asking for the material, for which material will help keep the food cold all morning.
Okay, so which material is going to stay cold longer, right? Okay, so what would tell me what information here tells me which one would be the best insulator?
Heat.
The specific heat capacity. Yes, that's very true. Okay, so we see the foam is 2,360 and the rubber is 1,250 joules per kilogram times Celsius. Sorry. So, which one would be better inside the lunchbox? The foam. Why? Why is it the best insulator?
Because the specific heat is higher.
It has a higher specific heat, absolutely. So that tells me that it takes, remember we talked about specific heat being stairs, right? So it takes, what if I was trying to climb this many stairs versus this many stairs? Which one would take longer?
The first one we talked
The one
about.
with
2,000, right?
Yes.
That's a lot more stairs to climb, right?
It's like twice.
Right, so it's going to take a longer time for that to cool down as well as heat up, which will keep your food at the right temperature for a longer period of time. Did I have to read the whole question?
No.
Did we read anything from up here? No, we didn't. We answered the question just fine. Okay? So that's also a test-taking strategy. The answer is foam. The answer is foam, but let's see. So we can eliminate these two answers, right? Best material to use is rubber because we said it's foam, right? So out of these two, it says the best material to use is foam since it's the best conductor or since it's the best insulator. Which one is the correct answer?
the insulator.
The insulator, why?
It says
Because you want to.
an insulator will help slow the transfer of heat.
Absolutely. When we say conductor, we're talking more so like electrical energy, right?
You want it to go through.
Right. So if we were talking about electrical energy, rubber might be the best conductor, right? Okay. All right, let's move on. Next. Okay. A force of 36 newtons causes an object to accelerate from rest to a speed of 12 meters per second in 6 seconds. What is the mass of the object? Okay. How do we figure this out? Does somebody use a particular equation?
Force equals ma.
Okay, force equals ma. Getting somewhere. Do they give us a force? What is it? Okay. And do they give us a mass?
No.
No, they're asking us to find the mass, right? Okay. And what about acceleration? Do they give us an acceleration?
No.
No, what do we have to do?
Find the acceleration.
They give us the information to find acceleration. Absolutely. Okay, so in order to find acceleration, what do I need?
Speed and velocity.
I need a speed, I need a starting speed and an
Speed
ending
and time.
speed, right? And time. Okay, what's my end speed?
12.
12. And what's my starting speed?
6. No. Well, no, we don't have this.
0.
How do you know that, Thomas?
This is from rest.
Yeah.
From rest. So that's a key word right there. That tells us we started at 0 meters per second. Very good. Okay, and then what is our time?
6 seconds.
6 seconds. All right. So what is our acceleration equal to? To what? Apples?
Meters per second squared.
Yes. All right. You guys are getting the hang of these units. Very good. Okay. So now we have a force of We have a force of
36 meters.
36 newtons, and we have an acceleration of, can we figure out our mass?
Yeah.
All right, cool. What is my equation to figure out my mass?
Mass equals F over A.
Okay, let's double check that. This is our triangle. Okay, if I want to find mass, it would be F over A. Very good. Okay, so then my force is 36. My acceleration is 2 meters per second squared. What is my mass come out to be?
18.
18 what?
18 kilograms.
Kilograms. Very good. All right, questions on that?
No.
All right, very good. Next. Yes. Can we get through the opening real quick? What did you get for that one? 18. It's okay, I'll post the video. I'm sorry. You good. I will post this for you guys today. Okay, a student conducts an experiment that involves the transfer of energy. The student places one metal spoon, one plastic spoon, and one wooden spoon in a glass that contains hot water. A small pat of butter is placed onto each spoon. Okay, so you see the diagram here. Okay, the pat of butter on the metal spoon is the first to melt and slide down. Why? So they're asking us which of these explanations tells us why the butter melted on the metal spoon first. Okay. What were some of y'all's answer choices? What did y'all choose? B? D. Okay, anybody else have something different? Okay, it says the metal material.
C.
You got B?
No, I mean
C.
Wait.
C?
Yeah,
D?
C.
Okay, let's look at C and D. Okay, the metal material transfers energy from molecular collisions up the length of the spoon the fastest, allowing the heat to reach the butter the fastest. Or the metal material condenses steam quickly, allowing the heat from the steam to warm both the metal spoon and the butter on it fastest. Okay. Why did you choose C? For someone that chose C, why did you choose that?
Because that's how conduction works.
That's how conduction works. Okay, how does conduction work?
Heat is transferred through physical touch. So like the molecules, when they hit each other, they transfer their heat,
Okay.
and it goes on up to the tip of the spoon, which touches the butter
Okay.
and lets down.
Okay, awesome. Yes, Thomas, you have something to add?
The metals material have condensed atoms, the molecules, so they are more likely to touch with each other and send that way.
Yes. Those are both great answers. And that makes me lean more towards C, I believe, right? Do we agree?
Yes.
Not only that, but the butter is touching the spoon, right? And we know that conduction happens with touch, right? Yes. Okay, so C is the correct answer. Very, very good. We're on a roll. Okay, next. What? We are. We're getting through these pretty quick. All right, question 4. All right, I don't feel like reading all that. I'm going to drop down here. Put the materials in order from the best thermal insulator to the worst thermal insulator. What does it mean to insulate again?
To trap.
Okay, to trap the heat, to keep it from changing, the temperature from changing, right? Okay. And what is going to be our best insulator here? Aluminum, concrete, copper, glass, or sand? Aluminum. Why?
Because it has a high specific heat.
Okay, so how do I know it's the highest?
It has 0.9.
Okay, so
It's closer
0.9.
to 1.
That's my highest number in the 10th spot, right? 98382. So aluminum is number one? It's the best. What's the next best? Concrete. Then what? Glass.
Copper.
Uh-huh. And sand. Very good. Does everybody understand why they're in this order?
Yes.
Let's see her. Put your phone up. Thank you. All right. Very good. So you have to drag the boxes. I'm not going to do that. But. All right. Last question. Then we're going to get started with copies of waves. Donald is heating water on the stove in a tea kettle. Which of the following best describes the process by which the water in the kettle moves during the time it's being heated? Okay, just look without the answer choices. What is happening here? What type of heat transfer? Convection. How do you know this?
There's current.
There's currents. Okay, so you see the cold water is coming down and it hits the heat source and it goes up hot and it comes down cold. Very good. Okay, so let's look at our answer choices. What did you guys choose? B? D. Anybody choose anything different?
No.
A.
A.
C. Oh, we got a few. We got all the choices in the word. All right, so we're looking at A, C, and D. Nobody chose D? Okay. Let's start from the bottom up. The water circulates due to convection, which is caused by molecules colliding with each other and transferring energy from the colder molecules to the warmer ones. Okay.
That's conduction. It's describing conduction.
Say that louder, Thomas.
It's describing conduction.
That sounds like conduction, doesn't it?
Yeah.
Molecules colliding with each other and transferring energy. Okay, so let's look at C. We'll get to A in a second. The water circulates in the tea kettle due to conduction. That can't be right? We just said that we thought it was convection, and that's true. Yes, so let's look at A. The water circulates in the tea kettle due to convection, which is caused by the motion of the warm and cold fluids due to their different densities. Does that make sense? I think that answer choice fits very well. Convection is the motion. There's movement, current of the fluid. Okay? Wonderful.